Welcome to another video explaining the universe using the particle model. Well, today's video is where I'm actually starting to do something different. I've had videos where I've titled them Ask Particle, not Quora. Quora.com is a place where you can ask science questions and get answers. And of course, with the particle model, don't always agree with those. Today's video will be on Csquared, and this has been prompted by a question asked by one of my viewers. But first, let me explain more about what's really happening here. Since August 22nd, 2017, that's when I made my first video, I've made 138 videos explaining the universe using the particle model. And I'm sure that some of my explanations were not exactly right, and there were times I made errors while making the video. But I have covered so many subjects that I've decided to move on. I may make a few more videos as the idea comes to me, or if someone asks about something that I haven't done. Actually, my emphasis is going to be in a different direction. I am going to do some testing. I'm getting started. I've got to learn how to use my new meter and play around with it for a while, and I will come back with that and give reports on it periodically as to how it's going. But if you have a question, ask Particle by posting a message in notifications. There's a little bell at the top of the website. You click on that bell and it gives you an opportunity to make a comment or write a question. Or you can send me an email at particleguru.com. I will only make brief comments like I'm doing today, normally brief, maybe more, but will give a particle model answer to your question. Oh, come on. Okay, I have a viewer. It goes by the name Just Saying, and he asks, this is a literal copy from the statement that he made. He states, what does it mean to say that a particle moves at c²? This requires a numerical value for c, and what value do you choose? If you define c as 1, then c² is still 1. But if you define c as 10, which is dividing the length of 1 into 10 parts per unit of time, then c² now becomes 10 times the value for c. So I responded, and this is what I said: I do not know the actual value of the speed of light. He was asking about G2. You got to start with light. And the particle model is always changing. The speed of light is always changing. It's being accelerated by the G2 gravity or slowed down. It's always changing. So there can only be an average. The G1 particle orbits the hydrogen atom, and it is the average of that speed, which I would say is c. Assuming that the speed of light is about 3 times 10 to the 8th meters per second, then c² is 9 times 10 to the 6th meters squared per second squared. Wrote that down wrong. That's one of his problems. It was the units. This is the assumed value of the speed of the G2 particle, which comes from a subatomic atom. This subatomic atom is much smaller than our hydrogen atom. The speed is needed in order that G2 gravity can control the flow of light, as in dispersion. Oh, Just Saying comes right back at me. Yeah. Thank you for responding. I'm trying to understand what c² means, because right now it doesn't make sense to me. Here's what I'm saying. If you measure c in miles per second, 186,282, then square that and convert back to meters per second and won't be the same value that you quoted. To simplify this, if I convert c from meters per second to light years per year, 1, and square that, it's still 1. And then he changes the subject slightly here, and so he's arguing about the units of c squared as a velocity, and he's right. It looks like, no, this is what I don't get about E equals mc squared. It looks like the c squared that's in the equation is not needed at all. E equals m is all you need. If 1 kilogram of mass contains 1 unit of energy, then 10 kilograms of mass will contain 10 units of energy. No c squared figure is needed. Well, what he's done here, right here, if 1 kilogram of mass contains 1 unit of energy, he's making a definition. He's defining energy differently than what is typically defined. And that's okay. You can do that as long as everybody follows the same rules. Well, my second response is, good point. My estimate for the speed of the G2 particle is based on the ratio of the speed of normal matter, which I'm going to call 30 kilometers per second, relative to the speed of the electron, which for the moment I'm going to say is the speed of light, is 3 times 10 to the 8th meters per second. If the ratio is the same for the speed of the G1 to the speed of the G2, then you get a value which is c squared over 30 kilometers per second. That's less than c squared, but it is in meters per second because you're dividing c squared by velocity squared by velocity. You get velocities. So the units come out right. So let's see what happens. Here's an estimate. For the speed of the G2 particles based on the ratio of the speed of normal matter, which is 30 kilometers or 30,000 meters per second, relative to the speed of light, which is c. So the speed of the G1 is to the speed of the G2 as the speed of the Earth is to the speed c. By the way, NASA fact sheet has the speed of the Earth at around 30 kilometers per second. So you take that equation and you solve for SG2, which is down here. You got to invert things. You end up with, if SG1 is also c, you get SG2 equals c squared over 30,000. Therefore, it's approximately equal to 9 times 10 to the 12 meters per second. And the units work in this case. So, that's the one way I made the estimate. And I said, well, that's not c squared, but it's fast. So just saying is right when he states that c squared implies 9 times 10 to the 16th meters squared per second squared, and that's not speed. Speed is in meters per second, not meters squared per second squared. So c squared, in quotes, is a label which was intended to indicate that the G2 had a very high speed. Not its actual value, because I don't know the values. I'm sorry for the confusion, but it's pretty much throughout my videos the c squared. So if anyone out there besides just saying is confused, I hope that clarifies it. But let's get over to his concern about E equals mc squared. I put the mass as capital M to make it different than meters. Energy is the product of force times distance, and this is where I claim this comes from. By definition, joules is equal to these are the units, kilograms times meters per second squared. This is force is mass times acceleration. That's what this is, mass times acceleration. And this is meters, and this is meters per second. That's the definition, not 1 kilogram equals 1 unit of energy. The problem comes when the units of acceleration is combined. It's combined with the units of distance, and they get meters per second squared times meter, and they combine it to the m meter with the meter to get meter squared, and they say, isn't this clever? It's v squared. This is where they lose the physics. V squared becomes just a number. It has no physical meaning. The physical meaning is up here. This is a physical equation and a definition. There's nothing physical. The object is not moving at v squared. It's changed, it's distorted the equation. So let's complete the equation. Anyway, you got, now I've gone to energy equals mass times meters over s squared times m, and I've done their little trick of mass times velocity squared. If you assume mass is moving at speed c, then you get this equation. Wow, isn't that amazing? Since this is part of Einstein's theory of special relativity, then at speed c, mass is infinite. You can't make the object, see, you lost the physics. The object's supposed to be moving at speed c and the mass is rest mass? No, it's not. Totally wrong. I don't know how else to say it. They've changed the thing to make a nice, pretty equation, and it looks neat, and you get all kinds of conversations about how energy and mass get converted back and forth to one another. Now, this is supposed to be a calculation of the energy, how much energy it takes to move an object m at some velocity. And this just was taken out to the extreme. Well, back to my c-squared. You could make the point that my use of c-squared is technically wrong, and I'm guilty. But I use the name to imply a very high speed for the speed of the G2 when I have no idea of what it actually is. My name is Bob D. Hilster, and I am your particle model guru. If you have a question, ask particle, not Quora. Thank you for your attention.